Another kind of reaction we're going to just touch on briefly is a single replacement reaction. And to recognize one of these, you always have an element by itself, and then you have an ionic compound. And what happens is that the element will come in and take the place of something in the compound. In this case, the iron is taking the place of the copper to be with the sulfate, and then the copper is displaced. So the thing to know is that only a more active element can replace a less active element. And so the more active element is iron, since it is doing the replacing. Another way to kind of see what's happening is that the more active element forms the compound. Sometimes you don't see the sulfate though. Sometimes you would just see the ions that are involved. And so the more active metal though becomes a cation. In other words, remember, cation is a positive ion, and here it is neutral, it has no charge, and here it's in an ionic compound, and we know that sulfate is -2, so this iron must be +2, and so it went to be a cation. If you have a reaction with nonmetals, a more active nonmetal becomes an anion, which is a negative ion. And the way to make sense out of this is that metals tend to give up electrons. That's what makes them metals. And so if they tend to give up electrons, they tend to become cations. And the better they are at giving up electrons, the more active they are as a metal. As far as knowing which metals are more active, it's not that simple. You can use an activity series, which is just a list you can look up in any chemistry book. Halogens though, and halogens are the fluorine, chlorine, bromine, and iodine. On the periodic table, they are in order of their activity, with fluorine at the top being the most active, and on down. So fluorine can replace any of the ones below it because it's the most active. It can replace any of those.